Yep.
Okay. Yeah, so as Yuri said, Chris Redpath was going to be giving this talk, which is not the title that you see there. The title is Why Can We Not Run Phones with Mainline Kernels? And so the story starts with the Android common kernel, so that's where we're going to start. I don't think we're going to use the whole time, and we're not going to go through this whole presentation from our boot camp thing, which is kind of a partner thing, but there's a couple of slides in here that are useful, and then we're just going to put the screen up and do fun talk. So we're not doing all that stuff. Go ahead. Go back a couple. Yeah, not. All right, one more. One back. Here, let me get it over. Okay, so we'll start there. So we have what we call the Android common kernel, which is finally, as of last year, downstream of the LTS kernels. Before last year, we created Android kernel every time there was an LTS kernel, but it never took patches from LTS. It was kind of a patch repository. Now it's a more properly maintained branch with CI testing and so on. And weekly we get the LTS merges down from Greg Cage, and he helps us manage that. So we are now managing them as kind of a proper superset of the LTS branches. And I say superset, and I'll stay on that one. There's kind of three classes of out-of-tree patches that we maintain on commons. One is features that are kind of very specific to Android. I give an example there of the interactive CPU free governor, because that one was never upstream, but really only used for Android. We actually don't use it anymore because now we use schedutil. But we have some other things that are kind of like that are very Android specific. We have some novel uses of UIDs in Android, for example, which impact some parts of the kernel. So we have a few patches, not huge ones. But we know these are ones that aren't going to be very interesting to mainline communities. I don't know if we've ever tried sending them upstream. I think there's been a few. But we have some patches like that are just totally Android specific that we maintain. We have another class, which are features that were posted upstream and rejected because of implementation issues for upstream. And I guess at the time they figured they kind of worked for us. I don't know that, I'm not really familiar with the ones of this class. We are going to be we're going to go back over all of these this year and really validate to ourselves whether we need to maintain these out of tree. So these are in that category, but there are some that basically we're carrying because we feel we need them. They weren't accepted upstream. I don't know the story, and maybe there's good reason. And then the last class of things are features that we really feel are ready for Android devices, but are still under development for being suitable for mainline. And EAS is in that category, where we've been shipping EAS now since our Pixel 1 device 2 years ago. And we're kind of proving out concepts in the products here that then are being part of that stream maintainer. So we expect every year now that this is going to be a much thinner and thinner set of patches. And so we have.
You write and get them other file system?
So we didn't write that, but it is. I think that one came. I think this one came from Samsung, and I think that there's a plan to submit upstream a version of this.
It's not FS2F, right?
It's not FS2F.
It's a Redpath.
So this one is. So we had this what we called Fuse FS, which was for the SD cards, basically fat file system. And in order to get rid of that, we needed an in-kernel version of that can understand the fat file system. And that's it.
Wasn't there a problem with the Microsoft piece?
There is a problem with Microsoft on that. So it's more of a legal issue than a technical one. And so anyway, so my understanding is that we've got this clean implementation that apparently is okay to go in the kernel. The version that we have here that we're carrying had to change the DFS layer that we know isn't right for upstream. So this one's not going to go upstream, but there is a version of this file system that probably will be submitted soon.
So this is the recap process.
Yeah. So and as a brief interlude,
Oh, that means other recovery.
Ja, det är sin G-file system for desktop going on. And the SDA also. I don't know if Microsoft is involved in that.
So will the pixels actually have an SD card slot in
I can't speak for future ones, but our past ones don't.
Yes, I know.
But we do support it. We actually do use it because we kind of simulate SD card internally for the user data. Okay, let's go to the next slide. Okay, so this is just showing, you know, where the common trees are. There's a whole bunch of it, and I'm not going to talk about, we're just going to talk about the main ones. We have a whole bunch of trees, generally corresponding to each of the LTS releases that we still have supported devices. So right now, we go back to Android 3.10 is our oldest one, and the newest one is Android 4.14. And then we also have a kind of a special one, which is the Android mainline tracker branch, which basically is rebased every upstream RC to be that RC with the Android specific patches on top of it. You get pretty close to mainline running Android or the mainline kernel plus Android patches.
Next slide.
Okay, yeah, next slide. Okay, so here's the big items that are in that list of patches that we're carrying. The top one this year is the Energy Aware Scheduler. But with all the activity, there's already a whole bunch of things that have gone in 4.15 and later, and we're expecting a bunch more throughout the year. So we expect this to be a really small one next year. Things go well. Then we have a bunch of special stuff in networking. Some of that is related to our peculiar use of UIDs. Some of it is some other stuff. SD card FS, a bunch of things having to do with USB, I think as the MTP support, and I think there's some audio-ish stuff in there.
Is that gadget?
Yeah, some gadget thing. You know, the changes are in the gadget area. Some changes down under Arch, the F2FS, which is now upstream, so that one will be gone. We have some driver stuff for input, and I think that that's not needed anymore, but it just needs to be validated, so that we may be able to drop that. We have an in-kernel debugger.
Is that really Android specific, or is that just KDB stuff thing?
I don't think it's Android specific, but I also don't think it's well tied to KDB either. So it's a special thing that folks have tools built on internally. So I don't think there's any plan to post that upstream either.
It depends on the secure mode focus in class zone too.
Right.
Because there's no NMI, so
So it says FIQ.
yeah, we are okay.
Yeah. And then we have Goldfish emulators are, you know, you get our development kits, there's an emulator, and that's some support for the emulator. Verity, and then a bunch of other little miscellaneous things. It's actually a pretty long tail. Many of those patches I don't think have been properly vetted for a while and may not be needed. So we're in the middle of kind of vetting this. So hopefully it's going to look a lot better next year. Next slide. And this is kind of showing the progression. So things are getting better over time. So this is at the day. This is you know, using the day that the Android common kernel was created from the upstream LTS. And so it's a pretty big patch set, about 450 patches, I think, overall is what we're carrying today. And we're hoping to converge that. But this is not why we can't run mainline kernels on phones. It's a contributor because it does mean you have to use this Android mainline tracker branch, but it's close to mainline.
So there is nothing like mainline, not out of being more.
Well, Bionic's a library in the Android tree.
Okay, but is there anything like that?
That's specifically for Bionic.
or specific for Android? Because it's not like that.
But yeah, so I mentioned there are some things that are implementing the way we use UIDs, and that is a little different, because we track a lot of things based on UID, because we map UID numbers onto apps, and we're tracking metrics about the apps using UIDs. And that has some fingers in the kernel. It's not that intrusive. It's a very small percentage of this, but that's an example of something that's very Android specific that doesn't really make sense upstream. We do have a few of those, but that's not the bulk of this. The bulk of this are those big items that I showed you, some of which are on their way upstream, some of which are deprecated. Okay, so that's all from that slide deck. But that's just an overview of the common kernel. Yeah, bring this. Okay, so when we do make products and phones for Android, there's sort of this hierarchy of kernels. So you've seen, at the top of the hierarchy is the LTS kernels, and then those merge down into common kernel. So if we're taking this year's generation of phones, that would be 4.9. Most of the ones that are being made for delivery this year are based on 4.9. Why 4.9? Well, we'll get to that in a second. And so then the silicon vendors, like Qualcomm, MediaTek, Silicon, whoever, when they're starting a project for new silicon for a year, they seed their kernel from common 4.9. So we'll just call this SoC, or some SoC vendor. And so they take Android 4.9, and then they go and put all of their SoC specific stuff on top of it. And it's not just SoC specific, it's other internal hooks and tools and all kinds of stuff. So it's not just cleanly drivers to support the SoC. In most cases, they've got some special instrumentation in various places in the core kernel, and it's a pretty large undertaking to bring this massive load forward from their last project and develop some new pieces. And so they start at different times, but we can think of it as roughly a year between when they start. They take the common and create their tree and bring all their stuff forward, test it, deprecate the things that don't make sense, add the new drivers, bring it up, test it on silicon, and get a working reference board about a year. And then they sell to they have partners, OEMs, who are going to be selling actual phones. And so then we have a device kernel, and that's the one that actually shows up on phones. And so there's another gap here.
But does the OEM add more special sauce?
And they may add more special stuff. They definitely add drivers, and and this is all very SoC vendor specific and OEM specific. So some of them are very turnkey and basically just take that and add the drivers that they need or whatever. Some of them take that and sprinkle their little hooks to measure certain things all over the place. So the intrusiveness of the changes are totally dependent on.
So would UPF might help with that, I guess. Like the hooks and stuff that are out of.
So BPF could help with some of that, except you're not only changing code, you're changing processes and scripts that no one's looked at for 5 years, and so
People, this is what people do that.
yeah, exactly. It's people and process and changing processes that have been, working for some number of years. Okay, so that means the first device is about 6 months, let's say. Obviously, these numbers they're not consistent; they're different per device, and but that means we started with 4.9. This was created shortly after LTS post, and so about 18 months after the LTS posts, we have a product based on that. So a 4.9 product comes out a year and a half after 4.9, which means that we're already, past 4.14 at the time that the 4.9 devices are going to run. The normal support length of a long-term support is 2 years, so we've got 6 months of support life left from it.
At that point, will you then back merge everything that you added to LTS and Common and wasn't taken up by the SOC and OEM back into whatever monstrosity is here at the end?
Will we back merge? Will we take the changes that were made here?
Will you take the changes that were added on
Here.
top of there?
Will they come down?
Will they come down?
Yeah, so in past years, until a year and a half ago, the answer to that would have been no. Basically, there's one arrow, one arrow, and
Yeah.
the end, and this thing, might be based on 4.9.10, and that's what it always is, and whenever you look at system, that's what it always be. That's not the case anymore, but it still differs by device and by manufacturer. But now, at this level, we're taking approximately weekly, so we're getting every LTS release. This varies by SoC vendor, but some of the SoC vendors are taking this every week. And then they're doing this a little less frequently. So let's say we're doing this maybe once a month until it ships or until it gets close to shipping. At some point they stop because they want to say, okay, we need to make this totally stable and ship it. And so then they ship a device. And then we don't know what happens. What we are recommending, what Google's recommending, and what we're trying to get the ecosystem to do is if there's a major release, so let's say they ship this device on Android O, and then we come out with a major release, an OMR1 or P, that between this original release and when they take their upgrade, that they would then get it upgraded, so that you would see instead of 4.9.10 for this MR1, you'd see 4.9.27.
You don't recommend they take kernel changes for all the security?
Well, so we are trying to get there, but there's a couple of things that work against us on that. The biggest of which is for phones, they have to go through carrier certification. And the carriers are, they've read their management software manager books from the 70s that tells them that for every N lines of code introduced, there's going to be M bugs introduced, right? So they're very nervous about taking patches. So what their policy has been, go through to not have to do a full certification every month when they're doing the security releases. They are willing to take the patches that are specifically specified in the Android security bulletin. So it's a monthly thing that goes out that says, it's got the issue numbers and the Android bug number and the patch or set of patches that fixes it. And that's a pretty finite set. So maybe for a given device in a month, there might be 6 or 7 kernel patches there, 4 or 5 of which are in drivers that are either from the introduced at this level or this level, and maybe 2 or 3 which came down from up there. And then only those specific ones that have CVE number and a patch, only those specific ones are in that monthly release. Otherwise, we trigger a full recall. So we're in the middle, and Greg KH is helping with this, of trying to educate the carriers and the OEMs that what they really want, if they want to be secure, is to take every single one of these, because there's a whole bunch of security fixes being made here that are not yet exploited and not yet published, but they're going to be. And you'd just be way better taking it all and being able to do that in the security release. So that's where we're trying to get. But we're thwarted in that right now, and we're limited to picking up everything at these major releases where they're going through full qualification.
Even for your own pixels?
Even for our own pixels. We have to deal with the carriers too, for our pixels. So yes, even for our pixels, that's where we are.
So running lineage is really actually much better.
Yeah. Well, so that gets us to the question of, well, why do we stay on 4.9? Well, okay, so this is 18 months later. Somewhere well before this, shortly after the year, the SOC team is now gone back and they're working on their next year's project and the shiny new thing. And the massive investment to rebase all of this onto the newer common for a phone that's already selling is the ROI isn't there for the SoC vendor. And so, we've been trying to evangelize the idea of doing your patches in a way that is amenable to switching the kernel out from underneath, kind of how we do the mainline tracker kernel, but that hasn't caught on because it's a lot of effort. And let's face it, from the SoC vendor's point of view, this was last year's stuff. And yeah, they sold a bunch of it, but now they want to get ready for selling next year. So basically where we are is once an SoC, and it means not only that SoC, but the whole derived family of that SoC. So usually the high-end one turns into a later mid-range one or a set of mid-range ones or ones for special markets. All of those are going to be using, for this SoC, 4.9. And nobody's going to ever rebase it.
So the challenge is to shrink the SoC.
The challenge is to somehow get it so that they can be more nimble so that the patches are better isolated. This is a cultural change, though. This is a really difficult one because they're used to this whole model, and in particular, they're used to kind of, once they get the SoC, that's theirs, and they're going to customize it to suit their needs for their products, and same with these guys. And so instilling this idea that you have to do all this extra work and architect your changes in a way that you can change the kernel underneath it is viewed as a lot of work for almost nothing, given that we've kind of moved on from this one and we're now on this new one.
But you can sell it that the return on investment because they don't have to. I mean, if they build a new SOC that is very similar to the old one, they have to rebase all the stuff they had last year.
Yes.
And if you make it easier,
Yes.
they
So
also make it easier for themselves.
So I mean, they're smart people, and they realize that point, and we've made that point too. And so, I think over time things are going to change. Things have changed a lot just in the last couple of years, just by being able to get any LTS patches to come down. So I do think things are going to get better here. And we have one. So I was talking to Pavan earlier. We have one case with Qualcomm where the SoC that was in the Pixel 1 is they're basically going to support that for a bunch of years, and so they have gone back and rebased that onto a much later one for the Dragon Board 820, which you can already get running 4.14 today, and it has all the SoC code for the Pixel 1, and so the question is how hard is it to finish the job and actually be able to run that kernel on a real Pixel 1, because then we would have at least one phone that you could, even though we just took it off the market from our store, so it might be hard to get them anywhere but eBay. But I think we may start having some isolated cases of particular phones which could be usable for mainline. And as we were talking earlier today, and testing kernel changes, scheduler changes, so that we don't stomp on each other. One of the things that's a real pain point for us on the EAS side is that any change we want to do, we have to bring it back to 4.4 so we can test it on a Pixel 2. So we have these mainline changes. How complex is it to backport it? Is it really a realistic test now that we brought it all the way back to 4.4? If we want to propose something for mainline, we're doing our testing of it on 4.4, or maybe we're using another development board like a high key board, which isn't really a phone, it isn't as highly tuned, but we can get a lot done with that. But we're in these sort of environments where we're kind of crippled on doing really thorough testing on mainline because we don't have this. And the things that we can run mainline are kind of weak representatives of the ecosystem and devices. So it would make our lives so much easier if we could sort of break out of this cycle and have phones that run mainline. But I do see it. I think we may have a few isolated cases in the next few years. I think, maybe 3 years from now, if we can break the cycle with the carriers and just make everybody more fluid about being able to.
Or make it easier to run the ROMs on.
Yeah. Yeah. So.
Saying,
Yeah. Yeah.
I know that you showed like nice numbers from and Google specifically, but the one thing that I would highlight is also the stuff. Maybe you don't have the numbers, but the stuff that the SoC tend to put in as well.
How much is it?
Yeah.
Pavan, what's the number? It's a lot. It's a lot. I would say, I think we estimate that a Pixel 2 phone is about 3.5 million lines of code generated there, and I think about half of that is mainline, half of it is out of tree. That'd be my guess.
Yeah, so I think this is also a big thing, because whenever you go back from when they are after the next year new stuff, they never send stuff back, so they keep on this mode of have to replace and a lot of time. That contributes a lot to your 1 year.
Yeah,
figure.
yeah, and I mean, there's a combination of reasons for that too. It's they're holding back IP that describes their chip that they're about to ship and stuff like that. Obviously, it's all out there when they ship it, but it's not a technology issue so much, I think, as
But if they would limit it to only those few things that are magic and special about the new one, but as far as I can tell,
Not only
from
the
one generation to the next, it's not everything that changes.
yeah,
A lot of it is
That's
very
true.
similar to the previous
yeah,
release.
it's true.
So
Some of it is too similar to the previous release and should be undone sometime, but yeah, it's a good point. And like I said, I think we're seeing some of that now with like the Dragon board. That's all going upstream, and so that's an instance of all the support that's needed for this SoC is getting merged upstream.
yeah, the Dragon board is 830.
This the 820 is one of the, yeah. So that one is equivalent to the Pixel 1. So, relative to this looks awful, but relative to a few years ago, it's way better. And I do anticipate things getting better as we go. So I think we're a few years away from very many phones being able to run mainline, but I wouldn't be surprised if in 2 or 3 years we do have some.
Is this something that Qualcomm itself is seeing and realizing?
Yes, yes, yes. So we are working with Lenovo and on once this, for example, this passenger connect listing. So we have been maintaining it for like 5, 6 years. Once it is one, so that we could actually make it out that.
Are there any other questions? That's all I had.
It makes me feel better. We have all that backwarding code into.
So you brought up the point about ROMs, but like if you have a rooted device, you can even, like, if you just want a command line, you can use the stuff I was talking about and get a root file system. Like if you want to run perf or.
I run ROM to get all the security updates because nobody cares about my phone.
Oh, so that's for your personal phone.
That's
not-
my personal phone. Yeah.
Oh, okay.
I simply refuse to pay like $1,000 for a new phone. That then has security updates for a year, and then I have to fork out another $1,000. It's just ridiculous.
We have 5 Pixel.
Yeah, but I just have an SD card in, and I just have a replaceable battery, and I'm probably screwed when this phone dies. Anyway. Yeah.
And what version of the kernel is your phone? You showed me the other day.
3.4. So yeah, great stuff. But it runs Android 7 now.
All right. All right, that's all I had.
And I do that.